Now, if we want to find positive coterminal angles, the way that we can do that is by adding 360 degrees to the measurement of the angle that you start with. So, for instance, in the example that I just showed, if you have a 30-degree angle, you can add 360 degrees to it, and that will get you 390 degrees. But you could also add any multiple of 360 degrees that you want to. For instance, if you do 360 degrees twice, you'd be adding 720 degrees. And you could do any multiple of 360. So, in that case, we have 750. Now, if we're talking about radians instead of degrees, then you would need to add 2 pi radians, because 2 pi is the radians equivalent to 360 degrees. So for instance, you'd be starting at pi over 6, or you could be starting at pi over 6. Add 2 pi to that, then you'd be at 2 1/6 pi, or 13 pi over 6. And you could also add 4 pi or 6 pi or any multiple of 2 pi, just like you could add any multiple of 360 degrees. To get a negative coterminal angle, the way that we do that, if we're in degrees, is we subtract 360. And so a negative coterminal angle would be negative 330 degrees. Starting at the positive x-axis, we'd go almost 360 degrees around, and that would put us right there to have a coterminal angle. You could also subtract 720 or any multiple of 360, and if you're in radians, you would subtract 2 pi or 4 pi, and so forth. Next up, arc length formula. So let's go back to our definition of radian measurement. Radian measurement is the arc length, which is s, divided by the radius r. So if we multiply both sides of this formula by r, we're going to end up with r times theta equals our arc length. So that's just something I want you to have in your back pocket if you need to find an arc length that's swept out by an angle. Next, circular sector. For problems like this, we have an angle and we've got a distance, a radius. Essentially, we've got a lawn sprinkler that sprinkles a distance of 20 feet and it swoops out a 30-degree path. And we have to know the area of the sector of grass that the sprinkler waters. Now let's remember what the area of a full circle would be. If this went an entire 360 degrees around, we'd find the area using pi r squared. So if this were a full circle, we would do r squared, 20 squared times pi. And so the area for the full circle would be 400 times pi. Now we notice that this sector isn't a full circle, it is a fraction of a circle. Then we ask ourselves, what fraction of a circle is it? Well, it's 30 degrees, and a full circle is 360. So essentially what we have here is we have 1/12 of an entire circle. So I know 1/12 of 400 pi. What is that? 1/12 times 400 pi. Put that 400 over 1. And then to simplify, I know that there's a factor of 4 in both of these right off the bat. 103. And so I multiply across and we get 100 pi over 3. And our unit is going to be square feet because our distance was regular feet. All right, next up. Reference angles. Reference angles are very important. We use this reference angles concept a lot in trigonometry. So for a reference angle, what a reference angle is it is the angle that's created between another angle's terminal side and the x-axis. And remember that this is an angle which is always positive. It's an angle that's always positive and it's always acute. All right, so 3 examples. First off, 150 degrees. Let's put this 150 degree angle in standard position. Initial side at the positive x-axis, terminal side will be a counterclockwise rotation of 150 degrees, and we're going to look something like that. So then, the reference angle for 150 degrees is the angle, which I'll do in blue, formed between the terminal side, which is here, and the x-axis. And for the x-axis, do the closest version of the x-axis. So that would be this part of the x-axis. So this is the reference angle right here for 150 degrees. Now, what's the measurement of this angle? If a straight angle is 180 degrees, and this one is 150, we know that this angle formed will be 180 minus 150, which is 30 degrees. And so the reference angle for 150 degrees is a 30 degree angle. Remember that it's always going to be positive and will always be acute. Add a little t in there. Next up, 5 pi over 4. For this angle, we are in radians. It can be helpful conceptually for students sometimes if they mentally convert it into degrees. Mentally or a paper pencil, whatever. So this in degrees is 225 degrees. Which would put us initial side. Terminal side would be past 180. Right in here. Reference angle is found in between the terminal side and the x-axis, the closest x-axis, which would be this one. So then we ask ourselves, what would this angle measurement be? The blue angle is 45 degrees past 180. And so the reference angle here is 45 degrees. Last up, 5 pi over 3. 5 pi over 3. If we convert this one into degrees, it is going to be 300 degrees. We do our simplifying and everything else. So this would start positive x-axis, go past 90, 180, 270, 300. So then our reference angle will start from the terminal side and go to the nearest x-axis, which in this case will be the positive x-axis. And what's that angle measurement in degrees? All right, so this angle here would be, what we'd said is 300 degrees. It's 30 degrees past the negative y-axis here. So if this is 30 degrees in here, this distance in here will be 60 degrees. For any angle on our coordinate plane, we may have to find the reference angle in future lessons. And so it's very useful for us to get practice with that. And that's our last topic for today. See you in class.